welcome to Math Molecules. This is part 3 of factorization of polynomials, which would cover factorization using identities. Please find the link in the description for part 1 of factorization using HCF and part 2 factorization using regrouping. Let's go ahead with the first identity. Factorization of binomial expressions expressed as difference of two squares. Here we would be using the identity a square minus b square is equal to a plus b into a minus b. So let's see how we can apply this identity. For example, if you have a question like this which says 9a square minus 16b square. So I have two squares and the difference of these two squares. So we have to check if we can represent the given problem in the form of a square minus b square. So if I see here the number 9 is square of 3. So I can write it as 3 square and we already have a square here. Similarly, 16 can be written as 4 square into b square, which again becomes 3a the whole square because I'm going to get the form a square minus b square here and it becomes 4b minus 4b the whole square. Now this is of the form a square minus b square, very similar to this. So it is a plus b. So the first term here is 3a. So I have to write 3a plus the next term which is 4b. Then a minus b. So here it is 3a minus 4b. So thus we have used the identity a square minus b square here. Let's take one more example. X power 4 minus y power 4. Now here it is a difference between the two terms which have the power 4. But we have to see if I can bring down to the same form as a square minus b square. Let's see how we can do that. So try out if I can write this term as something to the power of 2. So we know that 2 into 2 is 4. So it is x square the whole square. Similarly, y power 4, I can write it as y square the whole square. Now I got the form a square minus b square where a is equal to x square now and b is equal to y square. So a plus b, I will get x square plus y square and a minus b, I will get x square minus y square. Now I see that x square minus y square again is of the form a square minus b square. So I have to further reduce it. We have to keep doing the factorization till we cannot find any more factors. We stop there. So it is x plus y into x minus y. Now I cannot further factorize this. So this is the solution. Let's try out one more example. A power 10 minus b power 10. Now in this example, I have to see, as I find it is a difference, and now I have to see if I can represent them as difference of squares. Something like this. Something square minus the other number square. Can I do this? How can I do that? Because I know that 5 into 2 is 10. So a power 5 the whole square and b power 5 the whole square. And now a plus b, the first term, a power 5 plus b power 5 into a power 5 minus b power 5. So we cannot further factorize this. So this would be the final answer. Can we try out one more example? 12m square minus 27. If we see here, first take out the common factor. 3 is common. If I take out 3 common, then I have got 4m square minus 9. And then I get it in the form of a square minus b square, 2m the whole square minus 3 square. 3 into, now it is a plus b, 2m plus 3 into 2m minus 3. So in this part we learned how to use the first identity, the identity a square minus b square, difference of squares. Anywhere you find the problem can be reduced as difference of squares of given numbers, then apply this particular identity. Let's move ahead with the next identity. Factorization of algebraic expressions that can be expressed as perfect squares. Now here we would be using these two identities of a plus b the whole square and a minus b the whole square. Let's understand this better with an example. So if we have a problem like this, x square plus 4x plus 4, it is a trinomial. So just check if it is of the form a square plus 2ab plus b square. X square, yes it is, and then the last term can be written as 2 square. And let's see the middle term if it is of the form 2ab. Let's just see that 2 into first term is x into 2. This is the middle term we got, which is 4x. So it is of the form a square plus 2ab plus b square. So I can directly use the identity and write it as x plus 2 the whole square, which is nothing but x plus 2 into x plus 2. Let's just give another example. Maybe 4x square minus 12xy plus 9y square. Now here again, we will rewrite this and see if we can get the same identity here. So first term is 2x the whole square and the last term is 3y the whole square. Now let's see if the middle term can be written as minus 2 into 2x into 3y. So this gives me 12y, which is same as here. So now I can apply the identity directly, 2x minus 3y the whole square. Here we were trying to get the perfect squares. We checked if the identity of these squares could be applied. If there's a plus sign, then it is a plus b the whole square, and if there's a minus sign in the middle term, it is a minus b the whole square. This can be applied if you have three terms in the polynomial, if it's a trinomial. So in this video, we learned how to factorize using identities. More on factorization of trinomial would be covered in the upcoming video. Thank you so much for watching Math Molecule.